All right, here we go. Sum of cubes. We did difference of cubes yesterday, so today we're going to start with the sum of cubes. Now, just in case you forgot, when we are factoring, we always start by looking for something called the GCF, and GCF stands for greatest common factor. So right now we're looking at this right here, 16m to the third plus 2p to the third. What we're going to do is we're going to factor that. We're going to start by looking for the GCF like we did yesterday. This particular one does have a GCF, and that GCF is a 2. So we're going to factor that out first. That 2 multiplied with something will get me back to that 16m cubed plus 2p cubed. Question is, what is it? What do I need to multiply 2 with to get a 16m cubed? 8 what? 8m cubed. I also need to multiply that 2 with something to get 2p to the third power. What is that? 1p cubed. We can double check our work using some distributive property. That 2 times the 8m to the third gives us 16m to the third. That 2 times the p to the third will give us that 2p to the third power. That is GCF. That is our first step. However, we're not done. Now what we're going to do is we're going to take this part that's in the parentheses, and we're going to see if we can factor it some more, which we can. We're going to do this sum of cubes. We're going to do this part right here. So it's going to work just like yesterday. What I'm going to do is end up with a binomial times a trinomial. We're going to forget about this 2 for a minute. Right now, all we're working with is what's inside the parentheses, 8m to the third plus p to the third. All right, so let's get started. Let's find the binomial. First of all, we are talking about the sum of cubes, so my binomial should have a plus sign. So what else is going to go in there besides a plus sign? Well, what we're going to do is we're going to take the cube root of each one of these terms. So I'm going to take the cube root of 8m to the third power. And what is the cube root of 8m to the third power? 2m. How do I know that? Well, because that's what you get when you multiply a 2m times a 2m times a 2m. When you multiply 2m times 2m times a 2m, you're going to end up with this 8m to the third power. That's what it means when you're taking the cube root. What do I get when I take the cube root of p to the third power? You get a p. Why? Because when you multiply p times p times p, you're going to get that p to the third power. So that one takes care of the binomial part. Now we got to figure out what the trinomial is. Now, in case you forgot, yesterday I told you that this sign right here, the plus, and this sign over here will always be opposites of each other. In other words, if my binomial has a plus, my trinomial over here will have a minus. They're always going to be opposites of each other. Now, the last sign over here will always be a positive number. So what we need to do is we need to figure out what are the 3 missing parts here. What are the 3 missing parts of this trinomial? So what we did yesterday was we found the first part of the trinomial by squaring this 2m. So what do you get when you square a 2m? 4m squared. 2m times another 2m would give you 4m squared. Now I need to figure out what this middle part is. And to find this middle part, we're going to take both of these terms in the binomial and square it. Or not square them, but multiply. This 2m times that p, 2m times p is going to give me a 2mp. All I did was multiply those two together. To get the last part of the trinomial, we're going to take this p right here, and we're just going to square it. So what do you get when you square a p? A p squared. We just factored the trinomial. Now that's not the final answer though, because we do have one little thing that I need to put in there. Anybody know what I need to put in there to finish it up? 2. That 2 that we factored out earlier needs to go back in the answer here. So these are the factors of 16m to the third plus 2p to the third. In other words, if I were to multiply that big ugly thing right there, the answer I would get would be this little thing right here. Believe it or not. Okay. All right, so that takes care of difference of cubes and sums of cubes. I gave you one example out of each. Now you're ready for the test, right? No. Need you to get out that scratch sheet of paper that we were working with yesterday, guys, because I'm going to give you a couple more examples. One problem or one example is not enough. We're going to need more than that. So I got a couple more here to work. So we're going to look at these extra 3 problems. Some of them are sum of cubes, some of them are difference of cubes, but they work pretty much the same. So if you take a look at the first one there, we've got x to the third plus 27. And I want to know, what are the factors? What are the 2 things that we multiply together to get that particular answer right there? Now the first step is to always look for a GCF. Samantha, what does GCF stand for? Greatest common factor. And do we have a greatest common factor in the first one? No. Right? Yeah. No greatest common factor. So what we're going to do is we're going to try that sum of cubes. And I say sum because notice how it has a plus sign in it. So here we go. We're going to do the sum of cubes, which means I'm going to have a binomial times a trinomial. We're going to start by finding the binomial part. Now, because we are working with the sum of cubes, my binomial should have a plus sign. Now we're going to figure out what else goes in there besides the plus sign. Let's start with this first part here in the binomial. To get the first part, all we're going to do is take the cube root of x to the third power. And the cube root of x to the third power is a x. Because an x times an x times an x is going to give you x to the third power. Now here's where I may stump some of you guys. I need the cube root of this 27. Everybody know what the cube root of a 27 is? 3. Now there were a couple of you that knew it. So when I give you homework, how the rest of you going to do it? Can the calculator do cube roots? Yes, yes they can. As a matter of fact, get out your calculator. I want to show you where to find it because you may need it. What I was asking you to do was to find the cube root of 27. We know calculators can do square roots, but they can also do cube roots. The question is, where do you find the cube root? Because it's not the same thing as the square root button. Here's where you're going to find the cube root, guys. You're going to go to the button that says Math. Go to the button that says Math. And I believe it's number 4 that you're going to find. Number 4 says cube root. So select number 4. Then type in the number 27. And then hit Enter. And what does it say? 3. So anytime you need help finding the cube root of a number, just put it in your calculator. You'll find that underneath Math. All right, so we've got the binomial part taken care of. Now we need to come over here and figure out what the trinomial is. So let me remind you that since I have a plus sign right here, I should have a minus sign over here. The 2 signs are always going to be opposites of each other. The sign in the binomial and the first sign in the trinomial are always opposites. As a matter of fact, the second sign in the trinomial is always going to be a plus sign. Always, always, always. So now what we got to do is figure out what goes here, what goes there, and what goes there. And we're going to find all that information right here in our binomial. So here we go. To find this first term, we're going to take this x and we're just going to square it. What do you get when you square an x? An x squared. That's what goes right here. To get the middle part, all you're going to do is take both of the terms in the binomial, the x and the 3, and you're just going to multiply them together. Does anybody know what an x times a 3 is? 3x. That's what's going to go in the middle. 3x. So you get the last one over there. You're going to take the 3 and you're going to square it. What do you get when you square 3? 9. That's what goes in this trinomial over here. 9. You just factored x to the third plus 27. If we were to multiply these together using some distributive property, the answer I get is this little bitty thing right here. These are the factors of x to the third plus 27. Call that sum of cubes. Let's try another one. Look at number 2. Number 2 has 64 y to the third minus 1. First thing we're going to look for is GCF. Do we have a GCF on number 2 here? No, no GCF. So now I'm going to try that difference of cubes. And I say difference because this one has subtraction in it. So here we go. We're going to get a binomial times a trinomial again. It's like number 1. The only difference is now we got a minus instead of a plus. But all the steps that we just did, we're going to do them again. Now remember, I said we're working with a difference of cubes. So this right here should be a minus in the binomial. Let's figure out what goes inside these parentheses. I need to figure out what is the cube root of 64y to the 3rd power. Now I just showed you how to use your calculator to find cube roots. So find me the cube root of 64. Put that in your calculator if you don't know off the top of your head. All right? 4. But we're also taking the cube root of the y to the 3rd. And the cube root of y to the 3rd is a y. So there's your first term. We're also going to take the cube root of 1. Anybody know what the cube root of 1 is? 1. Because 1 times 1 times 1 is 1. So we're done with the binomial. Now we're ready to figure out what the trinomial is. As I mentioned earlier, the signs are always going to be opposites of each other. So that's a minus. So my first sign over here should be a plus. The last sign is always going to be a plus. So I got to figure out what goes here, here, and here. Here we go. Finding the first term. To find this first term, we're going to take the first term in the binomial and we're going to square it. So what do you get when you square a 4y? In other words, what's a 4y times another 4y? 16y squared. Now I'm going to get the middle part. And to get that middle part, we're going to multiply these two things together. The 4y times the 1. What do you get when you multiply a 4y times the 1? 4y. And the last part, to get this last part of the trinomial, we're going to take this one right here, and we're just going to square it. You know what 1 squared is, right? 1 squared is a 1. That last number over there is 1. We now have the factors of 64y to the 3rd minus 1.
Oh, we already explained why it was plus instead of minus.
Which, when this one right here?
Yes, sir.
Again, the reason we have a plus sign there is because these signs are always going to be opposites of each other. Just like up here, that is opposite of that. Always, always, always when we're working with difference and sums of cubes. This 2 over here will always be plus signs. Always, always, always. Okay, we're looking at number 3. We got 2x to the 3rd minus 16. First thing we want to do is look for GCF. 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 Greatest common factor. Now, we will tell you this one does have a GCF. The question is, what is a GCF? 2. So we're going to take care of that part first. So 2 goes on the outside. What goes on the inside? 2 times a what will give me the 2x to the 3rd power? X to the 3rd power. This is the first thing that I showed you. That was that GCF, greatest common factor. 2 times a what will give me a negative 16? There you go, negative 8. But we're not going to stop there, because if you look closely inside that parenthesis, we can do which one? The sum of cubes or the difference of cubes? Difference. We know that because it has subtraction. So for right now, I'm going to ignore the 2. It's not even there. I'm only looking at the x to the 3rd minus the 8. That's the part I'm working with right now. So I'm going to factor that. Just like I did the first 2, I need to find out what's my binomial and what's my trinomial. Now we are working with difference of cubes. So in my binomial, I'm going to have a minus sign. Question is, what else is going to go in those parentheses? Well, let's figure out what is the cube root of x to the 3rd power. X. What's the cube root of 8? Olivia, what's the cube root of 8? If you don't know, put it in your calculator. I'll show you how to do that. Cube root of 8. 2. So that's the number that should go right here. 2. Now we have the binomial. Now we need to figure out what goes into this trinomial. So, what's going to be my first sign right here? Plus. Why is that? Because these two signs will always be opposites. The last sign is always a plus. So now we need to figure out what goes here, here, and here. To get this first part, all we're doing to get this first part is taking this x and squaring it. So if I square the x, you're going to get a x squared. To get the middle part, we're going to take both of these and multiply them together. So if I multiply the x times 2, x times 2 is going to give me a 2x. And now I need to get this last part over here. And to get the last part, I'm going to square the 2. And if you square 2, you're going to get a 4. But that's not the answer. I'm missing one tiny little thing. The 2. Remember we pulled out the 2 earlier? So make sure you put it back in. These three things here are called factors. If I were to multiply all that big thing right there together, believe it or not, I'd get this little bitty answer right here. That is what we call difference and sum of cubes. So I just wanted to make sure we get a little more extra practice than just one thought. I don't think that would have been enough. All right, we're going to move on to the next part, so let's go back to the notes. Back in your notes, now we're going to look at 3 terms. At this point, we've looked at what to do when you have 2 terms, when you have a binomial. Now we're going to look at what do you do when you have 3 terms. So right here it says if we have 3 terms and the leading coefficient of 1. In other words, if there's a 1 in front of the x squared, what do you do? All right, I'm going to show you what we do, but just understand this is only going to work if there is a 1 in front of the x squared. All right, so let's get started. First of all, number 1, does it have a GCF? Is there something in common in all 3 of these terms here? What? 1. Anything that's bigger than 1? No. So 1 is the only thing, which is not good enough for me. There's nothing I can really do to factor out a 1. So we're going to try the next best thing. What I'm going to try and do here is I'm going to try and factor x squared plus 4x minus 12. In other words, we're going to look for 2 things we can multiply together to get that particular answer. Now, I will tell you, the 2 things that we're going to multiply together are going to be 2 binomials. A binomial times another binomial is going to give me this trinomial up here. The question is, what are those 2 binomials? Well, let's start with the easiest part, or what should be the obvious part, and that is the only way to get this x squared right here is by multiplying an x with another x. An x times an x is going to give you the x squared right here. The tricky part about this is figuring out what 2 numbers are going to go inside those 2 parentheses. What goes here and what goes here. Now we're going to have to play around with some numbers. So I'm going to come out to the side here and I'm going to do a little scratch work. Here's how we're going to decide what numbers go here. You're going to have to keep 2 things in mind. These 2 numbers that we're looking for, when I multiply those 2 numbers, they're going to need to give me a negative 12. But when I take those same 2 numbers, they also have to add up to a 4. So you got to keep those 2 things in mind. They got to be factors of negative 12, but they also have to add up to a 4. That's how we're going to determine what numbers go in here. So let's start playing with some numbers. Let's just start calling out some numbers that we can multiply together to get this negative 12 right here. Somebody give me 2 numbers that I can multiply together to get a negative 12. 2 and, well, it could be either way, right? We can do negative 6 times 2, or we can do negative 2 times 6. Both of those give me a negative 12, don't they? Okay. Now, those aren't the only thing. What else can we do? Negative 3 times 4, which means we could also do negative 4 times 3. Make sure you're putting these down on your paper, guys. This is a little scratch work out to the side. Anything else? About 1 and negative 12. About negative 1 and positive 12. Those would also give me negative 12, right? Now, we don't need all of those. The only one I need is the one that's going to add up to a positive 4. So we're going to go through all these that we've listed, and we're going to find the ones that add up to a positive 4. Anybody think they know which one's going to add up to a positive 4 here? Is a negative 6 plus 2 going to add up to a positive 4? No, so it can't be that. Is negative 2 plus 6 going to add up to a positive 4? Yes, bingo. That's the ones we want right there. So what I'm going to do is I'm going to use those two numbers in the parentheses. One of the numbers is the negative 2. The other one is the positive 6. Therefore, these are my factors. In other words, if I were to use that FOIL method we did the other day, the answer I would end up with would be the x squared plus 4x minus 12. These are the factors. So like I said, you're going to have to play around with some numbers in order to get that negative 2 and the 6. But as much as we're going to do it, you're going to get the hang of it. All right, let's go on to the next example they give us, which is this one right over here. 2x squared plus 10x minus 12. Now, before I do what I did on this first one, notice there is a GCF on this one. Anybody see what the GCF is? 2. So let's pull that 2 out first. Factor it out. Now, since 2 is the GCF, what do I need to put in parentheses? 2 times a what will get me back to that 2x squared. Very good, x squared. 2 times what will give me the 10x? 5x. And finally, 2 times a what will give me that negative 12? Negative 6. So that's the first step. That's the GCF part. But we're not done. Because now what we're going to do is we're going to take what's inside the parentheses, and we're going to try and factor that some more. So we're going to ignore the 2. We'll come back to that later. Just pretend it's not there. Right now we're only looking at this piece. What we're going to do is we're going to factor that piece just like we did number 1 here. So here we go. Here's what we did on number 1. In order to get that trinomial, we're going to multiply 2 binomials together. To get the x squared, we're going to need to multiply an x times another x. X times x is x squared. Tricky part is figuring out what 2 numbers are going to go inside it with those x's. Here's where we did the scratch. So out to the side somewhere, let's do a little scratch. Let's start finding some numbers that we can multiply together to get a negative 6. What are some factors of negative 6? Give me some numbers we can multiply together to get negative 6. Negative 1 and 5. What else? Negative 5, positive 1. What else? We're looking for numbers that we can multiply together to get a negative 6. Are those going to give us a negative 6, guys? No. Those don't give us negative 6. They give us negative 5. I want them to give me negative 6. There you go. Negative 6 times 1. That would give me 1. What's that? Negative 1 times 6. What else? Keep going. Negative 2 times 3. Negative 3 times 2. I think that's it, right? We got them all. Now, we don't need all of those. We only need the ones that are going to add up to a positive 5. So the question is, out of these that we've written down, which is the one that's going to add up to a positive 5? Let's try the first one. A negative 6 plus 1. Is a negative 6 plus 1 going to add up to a positive 5? No. So we're not going to use those. How about the negative 1 and the 6? Will those add up to a positive 5? Yes. Bingo. That's what we want right there. Those are the 2 numbers we're going to use in our 2 binomials. Negative 1 and a positive 6. By the way, it really doesn't matter which one you put first. If you put the plus 6 on this one and the minus 1 on this one, it's okay. Doesn't matter the order. We're almost done. There's just one little thing that I got to put in front of those 2 binomials. What is it? It's the 2 that we factored out earlier. So this right here would be my factors of 2x squared plus 2x or 10x minus 12. You got it. Now you're ready for the test, right? No. Let's go back to that scratch sheet of paper and let's take a look at 2 more of those examples. 2 more real quick. first example I have here is x squared plus 5x plus 6. Notice there is no GCF. There is no greatest common factor. So what I'm going to try and do is factor this trinomial. I also want you to notice right now there is a 1 in front of that x squared. That's important because if it's a different number, then we got to try something else. So just keep that in mind. So here we go. We're going to do just like we were doing a second ago. We know two binomials multiplied together will give me this trinomial right here. The question is, what are the two binomials? Well, x times another x is going to give me the x squared part. But we got to figure out what two numbers are going to go in the parentheses here. Here's where we do the scratch work. Out to the side somewhere, let's start looking for numbers we can multiply together to get a positive 6. Give me some numbers we can multiply together to get positive 6. Well, we'll multiply. 3 times 2, that'll give me a 6. What's that? 6 times 1. Anything else? Did we get them all?
You have to flip them?
Well, if I did 1 times 6, it's still the same thing. It's still the same number, so we don't really need to flip it. Okay. All right, so let's work with those two. Are any of those going to add up to a positive 5? The 3 and the 2, notice they add up to the positive 5. Therefore, those are the ones we're going to use. Those are the ones that we need to put in the parentheses. There's the positive 3, and there's the positive 2. Therefore, these are my factors of x squared plus 5x plus 6. If I were to do FOIL method, this is the answer I'd get. All right, let's try the last one there, and we'll move on to the last thing. X squared minus 13x plus 36. Same as this first one here. There is no GCF. So I'm looking for my two binomials. An x times another x is going to give me an x squared. That's the easy part. Tricky part here is figuring out what two numbers are going to go into parentheses. So out to the side, we're going to do the scratch work. And what I need to do is I need to look for some numbers that I can multiply together to get a 36. So help me out. Give me some numbers I can multiply together to get a 36. 4 times 9. What else? Negative 4. Ah, is that right, guys? Is a negative 4 times a negative 9 going to give you a positive 36? That is true. Are there any other numbers besides those two? 6 times 6, which means we could also use what? Negative 6 times negative 6. What's that? 3 times 12. So these are a few of them. They're not all of them, but there are a few of them. Let's check these, and let's see if any of them are going to add up to a negative 13. Let's go ahead and stop there and see if any will add up to a negative 13. 4 plus 9. Is 4 plus 9 going to add up to a negative 13? No. So that rules those out. How about a negative 4 plus a negative 9? Would those add up to a negative 13? Yes. Bingo. Those are the ones we want. Don't even worry about these others. We've already found them. So those are the two numbers we're going to put in the parentheses, the negative 4 and the negative 9. You just found the factor. And there it is. This is factoring trinomials. We only do this if it's a trinomial and only if there's a 1 in front of the x squared. We call that the leading coefficient. One last thing. Actually, it's not the last thing. We got this and then one more thing. We got something called trinomials, but this time the difference is our leading coefficient is something other than a 1. You'll notice in this example, instead of a 1 in front of the x squared, now we got a 6. So now we're talking a whole new ballgame. Now, in order to factor problems like this, they do have several different methods. We got something called guess and check. We got something called the box method. If you turn the page, everybody turn your page, up at the top there's something called the gross product. And right below the gross product, you also have something called bottoms up. All 4 of these are methods to solve or factor problems that look like this. I am not going to show you all 4. To me, I think I just confuse you more if I showed you all four. So, we are not going to do this. We're not going to do this. We're not going to do that gross product. The one I'm going to show you is that bottoms up. I'm just going to show you one method. Because I think out of those four, that one's probably going to be the easiest to remember. So that's the one I'm going to show you. By the way, this one, does it have a GCF? No, there is no GCF on this one. So what I'm going to do is I'm going to do all my work on the next page. So everybody turn your page, and we're going to look at the bottoms up. So you're looking at the bottom half of the page. Notice they gave you plenty of room. Why did they give you plenty of room to work in? So there's going to be some work involved. Okay. So what was the problem? I already forgot it. 6x squared plus 7x. All right.
Yes, sir.
Minus 5. This is the trinomial we're working. That's what I want to factor. We've already established there is no GCF, no greatest common factor. So there's a couple of steps involved. Our first step is going to be to take this leading coefficient and this constant over here, in other words, the 6 and the negative 5, and we're going to multiply them together. So what do you get when you multiply a 6 times a negative 5? Negative 30. So what I'm going to do is I'm going to rewrite this as x squared plus 7x minus 30. 6 times negative 5 was negative 30, so notice I put that negative 30 over here at the end. There is no more 6 in the front. Why did I do that? What is the purpose of doing that? Well, look at what I have now. Isn't this exactly what we just got through doing?
Yes.
Yeah, it's exactly the same thing. So I'm going to do the same thing we did earlier. I'm going to factor it, just like we did a second ago. An x times another x will give me this x squared. Now we got to figure out what two numbers are going to go inside here. So just like we did a second ago, off to the side, we're going to do some scratch work. We're going to play around with some numbers. What we're looking for are some numbers that we can multiply together to get this negative 30. So help me find some numbers that I can multiply together to get a negative 30. 10 negative 3. What else? Negative 10, 3. Negative 5 times 6. Negative 6 times 5. 1 times negative 30. Which means we could also use negative 1 and positive 30. That's about it, right? All right, so now we got some numbers to play with. Out of these that we've listed, we're looking for the ones that are going to add up to the middle number, the 7. Which of these are going to add up to a positive 7? Let's take the first one. Is 10 plus a negative 3 going to add up to a positive 7? Yes. So there's no need to mess with these other numbers. We just found them. So 10 and negative 3 are the numbers we're going to use. Now, a second ago, we got to stop, and we said, all right, that's the answer. We're done. We're not done this time, and that's because we had a 6 in front of the x squared. So here's what we're going to do. That 6 is going to come back into play. We're going to put that 6 underneath the 10, and we're also going to put that 6 underneath the 3. So now what I have is x plus 10 over 6 and x minus 3 over 6. Now notice we have some fractions here. And just like with anything else, if you can reduce the fractions, you're going to reduce it. So help me reduce 10 over 6. What do you get when you reduce 10 over 6? 5 over 3. Let's do the same thing with this one over here. I want to reduce 3 over 6. If you reduce 3 over 6, you get 1/2. Guys with me? Everybody know where my 6 came from, right? 6 is coming from right here. From there, I simplify. I reduce the fraction. What is this method called again? Bottoms up. Why are they calling this bottoms up? I'm about to show you why they call this bottoms up. The reason we're going to call this bottoms up is because when I have a fraction like I do here, we're going to take this bottom part, the 3, and we're going to move it up in front of the x. So instead of having x plus 5/3, what we're going to have now is 3x plus 5. That 3, that bottom part, is now coming up in front of the x. This is why we call it bottoms up. Bottom comes up. Matter of fact, we're going to do the same thing with that other one. That 2 that's at the bottom is going to come up in front of the x. So now what I have is 2x minus 1. Notice the top number is still there. The 5 is still there. The 1 is still there. So, you just factor. This right here is my factors of the 6x squared plus 7x minus 5. If I do FOIL, that's the answer I would end up with. So this one's a little trickier, and it's trickier because of this 6 that's in front of the x squared. It makes it a little bit harder. All right, so they only gave us one example to work with. That's not nearly enough, so we're going to look at a couple more here. Let's take a look at this next one. 2x squared plus 7x plus 6. This is on your scratch paper. And we're going to factor this one just like we got through doing. First thing we're going to look for is a GCF, which in this particular case there is not a GCF. So I'm going to factor it. So the first thing I need to do is take the 2 and the 6 and multiply them together. 2 times 6 would give us a what? 12. So I'm going to rewrite this as x squared plus 7x plus 12. There's the first step. Rewrite. Once I do that, now I'm going to factor that trinomial. So x times x is going to give me an x squared. Now I've got to look for some numbers to put in here. This is where we do our scratch work. Now the more and more you do this, guys, the better you're going to get at it. So, give me some numbers that I can multiply together to get a 12. 3 times 4. Now, before I start listing everything, let me go ahead and try 3 and 4. Let me see if they add up to 7. If they add up to 7, I don't need to write any more numbers down, right? So, 3 and 4, are they going to add up to 7?
Yes.
Yes. So do I need to keep listing numbers over here?
No.
No, you've already found them. So we just factored. But we're not done. Because remember, there's a 2 in front of the x squared. That 2 is now coming back into play. That 2 is going to go underneath my 3, and it's also going to go underneath the 4. Now, as we did earlier, if you can reduce it, reduce it. 3 over 2. Can you reduce 3 over 2? No. But I am going to do bottoms up. That bottom piece has to come up. I can't leave it a fraction. So that 2 is coming up in front of the x. So now instead of having x plus 3 over 2, now I have 2x plus 3. Let me go to the next one. 4 over 2. Now that is reducible. We can reduce that. 4 divided by 2 is a, what's 4 divided by 2? 2. So that now becomes a 2. There is no more fraction there, so there's nothing to bring up. Therefore, there's my factors. When you multiply those two things together, here's the answer you're going to get. A little tricky, right? Let's do one more. 4x squared plus 11x plus 6. I want to factor that. First thing I notice is no GCF. So we're going to do it just like we did this one. 4 times 6. 4 times 6 is going to be a 24. 4 times 6 is 24. I'm going to take that and I'm going to factor it. X times another x would give me the x squared. Now we're going to play with some numbers. I need numbers that I can multiply together to get 24, but when I add them up, they got to add up to 11. So let's start playing with the numbers. Give me two numbers I can multiply together to get 24. 8 times 3. Before I do any other numbers, let me check and see if those add up to 11. Are those two going to add up to 11?
Yeah.
Yes. So I don't need to try any other numbers. We just found it. 8 and 3. But don't stop there, because underneath that 8 and underneath this 3, we're going to put something. What are we going to put underneath those two numbers? 4. It's the number that's in front of the x squared. So 4 here, 4 here. If you can reduce the fractions, reduce it. 8 divided by 4. What's 8 divided by 4? 2. And then we'll come over here, 3 over 4. Can you reduce 3 over 4? No. But we are going to do bottoms up, which means we're going to take this bottom piece and we're going to move it up in front of the x. So now we're going to write that as 4x plus 3. Therefore, these are the factors. If I multiply those two together, here's the answer you're going to get. That's the answer. All right, guys, we're going to go ahead and stop right there.